Good day, everyone. I trust we are all good. Yeah, so you are welcome to our channel. And this video recording is about the solution to Med Paper 1 of May-June 2024. Till now, I've not seen the solution anywhere on the internet, on YouTube, and on the various Department of Education website. And I know that the exam is fast approaching, hence the reason to work out the solution of the paper, the last Med Paper 1 that was written, and to publish it so that you learners, you can go through the solution and you can better prepare yourself for the forthcoming October-November exam. All right, let's get to it. So we are answering question 1.1. And before we go on in this video, special reference to South African exam papers. I downloaded this past question from their website. And as at the time I downloaded the paper from their website, the memo is not yet available. And the memo is not available on any other social media, including YouTube. So to me, this will be the very first video recording of this solution. So let's get to it. Question 1.1 says that we should solve for x in this equation, 3x squared plus 5x equal to 0. So this is a simple factorization question. It's a simple factorization question. So this is the question. If you look at the first term is 3x squared and the second term is 5x. Those two terms have x in common. So we factorize with x. And that is what we have here. We are factorizing with x. So you can see x is here. Then here you have 3x plus 5, and that will be equal to 0. You can set this x to 0 directly, or you can set the content of the bracket to 0. So in the next step, we have x equal to 0 or x plus 5 equals 0. This first solution, there's nothing you can do to reduce it or to simplify it because it's already in the simplest form. But this second part of the solution, 3s plus 5 equal to 0, you can simplify that further by transferring the plus 5 to the other side. It becomes negative 5. So we have 3x equals negative 5. So, okay, so this plus 5 is not there. So we have that. So next, we make x the subject of the formula. So if we make x the subject of the formula, you will see that x is equal to negative 3 over 5. So x is equal to negative 3 over 5. That is the solution to question 1.1.1. Let's move to question 1.1.2. And the question says we should report our answer correct to 2 decimal places. In matric exam, whenever they give you a quadratic equation and ask you to express your answer to a specific number of decimal places, it means that that equation is not factorizable. So the easiest way to go about it will be to apply the quadratic formula. The quadratic formula is available at the back of your answer paper on the formula paper. And this is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Now, let's spell out what each of those variables represent. Variable a represents the coefficient of s squared, in this case 4. Variable b equals the coefficient of x, which is 3. And variable c is the constant, which is negative 5 in this case. So next, you just need to make appropriate substitution. And when you substitute, you have all this, and you can punch everything directly into your calculator So you just use this key. Then we have -3, -3. So you cannot do plus or minus together. So you do them separately. So plus the square root of b squared. So that will be 3 squared minus 4 bracket 4 multiplied by -5. You close the bracket. Then you use this down arrow. Then 2 times 4 is 8. 2 times 4 is 8. Then you just click here. Then you can finish your calculation here. So you can see the answer here is 0.80. Remember, we were told to approximate our answer to 2 decimal places. Now, let's look at the value of x when this is negative. Remember, you have plus or minus here. So you just use your left arrow to move your cursor until you get to that plus, and you can delete, and you put your negative there. And so the second root will be -1.55. All right, for those of you that would like to do it manually, if you want to challenge yourself, so I've prepared the procedure step by step here to help you with that. So we simplify, we drill down, because sometimes it's good to know how to do this manually in case you are dealing with an exam that does not require you to use calculator. So you should be able to know how to work this out manually. So you can see here that what we got here is the same as what we got when we use our calculator. Now let's go to question 1.1.3. So in question 1.1.3, we're given this quadratic inequality, s minus 1 all squared minus 9 greater than or equal to 0. All right, so let's see how that works out. So what we do is, let's try to simplify things. So this x minus 1 all squared is the same thing as s minus 1 multiplied by s minus 1. And remember, this -9 is here and greater than 0 is there. So next, we see if we expand x minus 1 multiplied by x minus 1, we will get x squared minus 2x plus 1. Then don't forget this -9. You set everything greater than or equal to 0. If we simplify this, we would have this. So it will be +1 minus 9 is -8. Then we can solve this quadratically. And what I do advise my learners to do is that just pretend as if this greater than or equal sign is not there. Set this equal to 0 and solve the equation quadratically. So that is what we did here. So we just set to 0. So here you can factorize this, or you can solve using the quadratic formula. Using the quadratic formula, you click here, then minus b will be minus minus 2. That gives us +2. Then plus the square root of -2 squared, -2 squared. Then, okay, let's do something here in order to avoid mistake. Yeah. So I'll just delete this. I'll put this in bracket -2. Then I bracket it, then squared. Then -4 multiplied by, then we have a, our a there is 1, then times c is -8. Use this -8. Then I close the bracket. I use the down arrow. Then we have 2 times a, 2 times 1, that will be 2. then we can enter this. So you will see that x is 4, or let's look at the solution when you have minus. So when we have minus, you could see the solution will be -2. For those of you that like to solve things manually, so you can factorize. When we factorize this equation here, x squared minus 2x minus 8 equal to 0, can be rewritten as x squared plus 2x minus 4x minus 8. Then we have to split that into 2 equal parts. And when we factorize for the first component, x is the common factor. So we have x into x plus 2. Then for the second component, -4 is the second component. So we have -4 into x plus 2. You set everything to 0. Then you collect the common factor outside of the bracket. You keep those in one of the brackets. Then you can take the content of one of the bracket and set everything to 0. So here, we set the content of each of the bracket to 0, and you can see x minus 4 equals 0, or x plus 2 equals 0. Now, let's finally solve for the value of x. So you can see that x equals 4 or x equals -2. Now, we have to be careful here. Remember, we are dealing with greater than or equal to. So we are not dealing strictly with equal to. If you are dealing with equal sign, then this will be your final answer. But you must remember this inequality here. So that means that this is not the end of the solution. So what I do encourage my learners to do is to draw a number line. So on the number line, you represent the two roots of the equation. You represent the two roots of the equation. In this case, you have 4, and here you have -2. So you set a boundary around the two solutions, which are -2 and 4 in this case. And within that boundary, you will have a region called region B. Now, to the left of the lower root, which is -2 in this case, you will have another region to the left of this -2, that is the values of x that are less than or equal to -2. So those will be to the left, and that will form region A. To the right of the upper root, which is 4 in this case, you have region C, which are values of x greater than or equal to 4. Now, we have to test each of those regions to see the region that fulfills this criterion. The criterion here is greater than or equal to. And you know, if something is greater than 0, it means it's positive. So we want to look at the region which is positive in this case. Now, let's see how we can do that. The first region we'll be testing is region A, and we'll be testing region A with -3, since -3 is to the left of -2. So if we test with -3, let's see what we have. If you substitute -3 into this original equation, you can also substitute it into this, you will have the same result. So if you substitute x equals -3 here, you will have +7. So that is the reason I put this positive sign here. So it means that the inequality will be positive for all values of x less than -2. Now, let's look at region B. Let's look at the sign we have in region B. And for region B, we'll be investigating with 0. So 0 is between -2 and +4. So I always tell my learners, when you are investigating this region, do not use the root exactly. You must use a value of x that lies between the two roots, any value of x that lies between the two roots. That is why we chose x in this case. Now, if you substitute x equal to 0 into this equation, you will get -8, which is negative. So that means that the inequality will be negative for all values of x that lie between -2 and +4. Now, let's test for region C. For region C, we will use a value of +5, since 5 is to the right of +4. So if we substitute 5 into this equation, we will get +7. So which means that all values of x greater than 4 will result in this inequality being positive. So you can see for region A and region C, the inequality would be positive. And those two regions satisfy this inequality here. So that is why you saw that this arrow is going to the left of -2, and it's also going to the right of 4. And you will see here that I used a solid circle. I use this solid circle because we are dealing with greater than or equal to. If it were greater than only, this circle would be open. But because you are dealing with greater than or equal to, then you have to shade. This circle must be solid. Now, it means that the solution to this inequality will be all values of x that are less than or equal to -2, or all values of x that are greater than or equal to +4. And you can see that there is no linkage between regions A and C. So you cannot combine those values together, right? So you write those values separately as x less than or equal to -2, or x is greater than or equal to +4. So that is the solution there to that question 1.1.3. And in that question 1.4, they want us to solve this exponential equation. To solve this exponential equation successfully, you would have to look for the term with the lower exponent. In this equation, we have two terms, 5 exponent 2x and -5 exponent x. In this type of equation, like I said, you will look for the term with the lower exponent. The term with the lower exponent here is 5 exponent x. So you set that 5 exponent x to any alphabet other than x. So in this case, we are using letter K, alphabet K. So we say let K equals 5 exponent x. And there is a reason I said you must use the term with the lower exponent. If you use the term with the higher exponent, there will be a problem later on when you are doing your calculation. So to make life easier, and the correct way to do this is to equate this K to the term with the lower exponent. And in this case, that is 5 exponent x. So now, if you look at the first term, 5 exponent 2x, 5 exponent 2x can be rewritten as 5 exponent x all squared. And you know that 5 exponent x itself, it is k. So that means all this will be equal to k squared. So it is that simple. So now we will make appropriate substitution into the original equation. So here, instead of writing, you substitute k squared for 5 exponent 2x, then minus, you substitute k for 5 exponent x. Now you can factorize with k here. So if we factorize with k, we have k bracket k minus 1. You can set this k directly to 0. So that means k will be equal to 0, or k minus 1 equal to 0. There's no way you can simplify k equal to 0 further. That is the simplest form. Well, we can further simplify k minus 1 equal to 0. That means k will be equal to positive 1. Remember, the question says we should solve for x, not for k. So we still have to solve for the value of x. So to solve for the value of x, let's look at what happens when k equals to 0. When k equal to 0, you come here and you just put 0 equals 5 exponent x. So if you set 0 equals 5 exponent x, how do we solve for x? One way we can solve for x here is to bring this 5 to the other side. You know, if 0 equals 5 exponent x, it means 5 exponent x equal to 0. In that case, how do we solve for this x? Well, we have to take 5 from one side, and remember this 5 is a base here for this exponent. So when that 5 gets to the other side, it will become the base of a log. That is what is happening here. So x will be equal to log 0 base 5. If you punch that into your calculator, this is what you will use. Log 5, log base 5, then 0. That is log 0 base 5. That will result in an error. So there is no solution there. Now, let's look at the situation when k equals 1. When k equals 1, then we can set 1 to 5 exponent x, just like this from this point, right? We can set 1 equals 5 exponent x. Remember, any number raised to the power of 0 is 1. The only exception there is 0. If 0 is raised to power 0, then it will be 0. But any other number, be it positive or negative, any other number raised to power 0 will give us 1. So that is the reason we set this one to 5 exponent 0. Since the base is the same on both sides, you can cancel the base and you equate the exponent to each other. So that means that x will be equal to 0. That is the solution to question 1.14. Then question 1.15. So question 1.15, for question 1.15, we have x divided by the square root of 20 minus x equals 1. So that is the question we have here. So we can rewrite this on the right-hand side by saying 1 divided by 1. 1 divided by 1 is the same as 1. So if we cross multiply here, we would have x equals the square root of 20 minus x. If you cross multiply, 1 times x will be x. Then the square root of 20 minus x times 1 remains the square root of 20 minus x. Now, when you are solving this kind of a question, the next thing you have to do is to find a means to remove this square root. The easiest way to do that is to square both sides. So you square both sides. And when you square both sides, you have this. So x squared, if you square x, you will have x squared. Then if you square the square root of 20 minus x, this is what you will have. So what this square does is to remove the square root. Very simple, and it will make your life easier. So this square root is removed now. You have 20 minus x on the right-hand side. Now, all you need to do is to transfer the content on the right-hand side all to the left-hand side. And that gives x squared. By the time this negative x gets here, it becomes positive x. By the time positive 20 gets here, it becomes negative 20, and you set everything to 0. Now, for those of you that like to challenge yourself, you might decide to solve this manually by factorization or using the quadratic formula. So this equation s squared plus x minus 20 equals 0 can be rewritten as s squared minus 4x plus 5x minus 20 equals 0. And you can factorize it from here. All right. So nobody compels you to factorize. So you can use your quadratic formula and let's punch in the values. So this will be minus 1 plus, we do plus first, plus the square root of 1 squared. So the square root of, okay, 1 squared is 1 times 1, right? So that remains 1. Then minus 4. Then multiply by a, which is 1. Then multiplied by c, which is negative 20. Negative 20. Then everything divided by 2 times 1. So here, if you punch in for the plus sign, the answer here will be positive 4. That will be positive 4 there. Then let's look at the situation when the sign is negative. So when the sign is negative, the answer will be negative 5. So those will be the two values of x. Now, for those of you that like the manual way, especially when you are preparing, so we factorize like this. Then you collect the terms outside of the bracket. So that means x plus 5 multiplied by x minus 4 equal to 0. So you can set the content of each bracket to 0 like that. And you see that x equals negative 5 or x equals 4, which are the same result we got on the calculator. So that is question 1.1.5. Next, question 1.2 is a simultaneous equation. So we have that equation 1, x plus y equals 9, and equation 2, 2x squared minus y squared equals 7. What we can do here is to make x or y the subject of the formula from equation 1. So from here, I made x the subject of the formula in equation 1. So that means x will be equal to 9 minus y, and we can make that equation 3. Next, we can substitute x equals 9 minus y into equation 2. So if we do that, we have 2 into x. So instead of writing this x, you write the value of x here, which is 9 minus y. Remember to square it, then minus y squared, and everything will be equal to 7. Then you will have to simplify this. 9 minus y squared is the same as 9 minus y multiplied by 9 minus y. And if you expand that bracket, you will have 81 minus 18y plus y squared minus y squared equal to 7. You can expand the bracket with 2, and you have 162 negative 36y plus 2y squared minus y squared equals 7. So what we can do now is to bring that 7 over to the left-hand side. So that will be 162 minus 7, and that gives us a value of positive 55. Now, we can solve this equation quadratically. You can factorize. So you can rewrite this equation as y squared minus 5y minus 31y plus 155, and you set it to 0. So let's solve it using calculator first. So using our calculator, we click on this button, then we come here, So B is negative 36. So we have negative 36. That will give us positive 36 plus the square root of negative 36 squared, negative 36 squared, then minus 4 into A. Our A is 1, then multiply by C, which is 155. Close the bracket, then use the down arrow to come down. Then we have 2 times A. That will be 2 times 1, which is 2. So the result of this will be 31. So that means that one of the results of Y, or one of the values of Y, is 31. So next, let's look at the solution when we use negative sign. So that will be 5. So that means that Y could either be equal to 31 or Y equals 5. Those are the two values. So we are still factorizing here. For those of you that would like the manual method, if you want to follow the manual method, you can just follow these steps. So we have Y equals 31 or Y equals 30 or Y equals 5. So next, we have to calculate the corresponding values of X. And that is very simple. All we need to get the value of X is to substitute each of the value of Y into equation 3. And once we do that, let's look at the value of X when Y equals 31. So when Y equals 31, X will be equal to 9 minus 31. And that means that X will be equal to negative 22. So we can write the values of X and Y in the coordinate form. So that means X is equal to negative 22 and Y equals 31. Let's look at the value of X when Y equals 5. So we substitute Y into the same equation 3. So that means that X will be equal to 9 minus 5, which means that X equals 4. We can also write both values in the coordinate form like this, which means that X is 4 and X is 4 and Y is 5. Remember, when counting from A to Z, the value X comes first before Y. So that is why you always write the X coordinate first, followed by the Y coordinate. So for question 1.3, they said that given that P equals 1 minus A and T equals all this, determine the value of P times T in terms of A. So this question 1.3, sometimes it comes in question 1.4. It's always a high order question. So what I do advise my learners to do is that look at it very well, because it's always a very tricky part. Do something there at least so that you can at least get 1 or 2 marks, and sometimes you can be fortunate to get the full marks. But don't waste your time on that question. If you don't have a clue to the question, you can go on with other questions and you can come back to question 1.3 or 1.4 later on if you have sufficient time. So I've tried different ways to solve this question 1.3, but one of the ways you can use, or one of the methods you can use to solve this question 1.3 is a specific case of cyclotomic polynomial identity. That is what I will call CPI going forward, because I don't want to bore you with big terms. So cyclotomic polynomial identity, and I will use CPI for it. So we'll use a specific case of CPI to solve that question 1.3. So the whole of this T, we can rewrite it, and let's see how we can do that. So you can see T equals 1 plus 2 t equals 1 plus a to the power of 2 to the power of n, right? And there's a lower limit and an upper limit. The lower limit here is 0 and the upper limit is 9. So it means that the first term of this sequence would be, so it means that the first term of this equation, would be obtained when n equal to 0. So if you substitute n equal to 0 into this, you would see that you get the first term. The second term would be obtained when n equals 1. If you substitute n equals 1 into this, you will get the second term. And the third term will be when n equals 2. If you substitute n equals 2 into this, then you get this, right? And here you have a exponent 512. All right, so we will see how that works out in a moment. So all these equations we have here can be written in this form, right? It can be written in this form. So all the expression here can be simply written as 1 minus a exponent 2 exponent n plus 1, everything over 1 minus a. So now, the n we are dealing with here, the last value of n here is 9. And if you look at 2 exponent 9, 2 exponent 9 will give you 512, which is what you have here in the question, right? So if we go back to this specific case of CPI, we can rewrite that t. So it means that t will be equal to 1 minus 2. No, it means that t will be equal to 1 minus a exponent 2 exponent 9 plus 1. Remember, you have n plus 1 here. Everything divided by 1 minus a. So it means that t will be equal to 1 minus a exponent 2 exponent 10 divided by 1 minus a. So here it means that t will be equal to 1 minus a exponent 1024, because 2 to the power of 10 will give you 1024, and everything divided by 1 minus 2a. Now, we can then do p times t. So p, as we are given in the question, is 1 minus a. So that is the same as 1 minus a over 1, then multiplied by t, which we have already obtained here. So 1 minus a cancels 1 minus a. So eventually we have the value of p times t. So p times t will be equal to 1 minus a to the power of 1024. So that is the solution to question 1.3. So you can experiment this to prove if this works or not. So you can experiment a with any integer. You can use a equals to 2, substitute it into this question and work it this way and see if you will get the same solution, if you get a correct solution. So I've tried it and I saw that it worked. So this is the method that you would use to solve that question 1.3.